Alright guys, welcome back to the Average Reloader. What we got on the bench today, 270 Winchester. Deer season is coming up in a couple months, and I figured this would be a good video to try out a new reloading tool that I downloaded. It's called Gordon's Reloading Tool, GRT for short. Basically, in my eyes, I see it as a shorter way of doing the Satterley method to find your nodes. So we are going to do a run through on that. But basically what we got, 270 Winchester. All of this is probably twice fired Winchester and Hornady brass that I got. We are using a 130 grain SST Hornady. I usually shoot the 130 grain nozzler ballistic tip, but haven't been able to get my hands on some of those. So that's what we're going to do, is use work up a load for the SST. Powder of choice is H4831 SC. I don't quite know if this is going to be the perfect powder for this. It worked great for me for the nozzler, but according to the tool that I'm using, it has an insufficient burn rate for what we're using, so we may come up with some inconsistencies in our numbers in the program here. So let me just go ahead and get this pulled up. So what I got is a Ruger American, chambered in 270, obviously. It's their black one. It's not the Predator or anything like that. It's just your base Ruger American. It has a Nikon 4-12 or 3-9 Buckmaster's 2 scope on it. Nothing fancy. It's just a hunting rifle. That is strictly what it is. For whitetail, that's the only thing I've used it for. Alright. Well, after you spend all the time trying to figure out how to download this, you should come up with something close to this. Move the camera here a little bit. Alright, so you probably need to be somewhat pretty experienced in reloading to use this. I'm just going to say that now, otherwise all of this is going to seem extremely confusing. So you want to start with your caliber or cartridge. That's over here on the left. You're going to pull that up, and it's going to give you a drop down. Now, I do a lot of Wildcat stuff, and I've tried to use the Wildcats on these, and the biggest thing that you have to have is your bore correction, which is over here. It's called the cross section, which comes from the measurements of your bore. Pretty much it's just kind of like a resistance reading, I guess, to help them get a number on how much pressure it takes for the bullet to squeeze into the bore. So that being said, like, you got to be pretty versatile to use this tool here. So, but as far as like basic, like the 270, that's why I'm doing this video for the 270. It should be fairly straightforward, especially the way they explained it in one of their videos. So we're going to find, move this over here a little bit. 270. And there's actually a decent amount of cartridges on here for what it is. You know, we wouldn't expect to see some of them. Like, they got the 6GT, 6 Dasher, you know, 6x47. They got all of those on here. You know, even though they're not actually mainstream cartridges, they have got some data on them. So 270 win. Then we're gonna select values and apply. So when you pull that up, these are all of the values, clicking on this cartridge, that it's going to apply here. Okay, I know some of these measurements are in metric. We're gonna change that here in a second. So you wanna make sure on here that you got everything selected on there since you're starting from scratch. The pre-selected caliber was 6.5 Creedmoor. It's going to go to 270. It just shows you the changes that's going to be made. So hit OK. Yes. All right. Pulls it up over here. We're going to change. Nope. I'm going to find. Oh. So hard to hit everything on here because it's so small, being on a tablet. All right, we're going to go to view, and we are going to change all units to imperial. All right, there we go. All right, the next thing we're going to do is we're going to choose our bullet. Click up here at the top of that. This little warning pops up every time you get in there. You just hit cancel. Let's drag this over here so we can see it. All right, let's just make it big. We're gonna scroll down to Hornady, and they got all kinds of bullets on here. There's the Sierra. We went too far. Okay. Hornady, 277. We are going to go SST 130 grain. We're going to go select values and apply. All right. Now, every time you select a bullet from their database, the projectile length is not selected to apply the value. If you're just trying to get a general idea of a load, you can select it, but they highly recommend that you measure your own projectile, because there's variances, you know, in manufacturing process that can cause, you know, maybe the die's worn out that they're punching these things out with or forming them with. So those variances, they want you to take into account so you can get the most accurate data from this tool. This is an important part of the tool, is the projectile length. So for right now, just for explaining all this, we're just gonna use the projectile length that they have in here. So we're gonna hit OK. This is just a warning about the projectile length. It's just an average value that can deviate significantly from the real situation. All right, we're just gonna hit yes. All right, pulls it up. Now, we're gonna come down here, we're gonna choose our powder. We're going to drag this over again. We're going to go up here to Hodgdon. And 4831. We're gonna hit OK. All right, now we got cartridge, bullet, powder loaded in there. Go ahead and exit out all of these. So right now, our charge weight, it just shows 41 grains in there. That must have been what was previously in there. If you're just using this to get a starting load or something, consult multiple load datas to kind of line up a good starting charge weight, and you'll that way you can get a general consensus. It'll kind of show you where you'll be at and your pressures. These are just like average numbers. I mean, it's not specific to anything that you got yet because you haven't done the important step here, and that's going to be to measure a fire formed case straight out of your chamber, fresh firing on it. They want you to measure the case capacity. That is also another big factor here, and it's a really big factor to helping find your optimal barrel time, which is right here. We'll get to that in a second. I'm gonna go ahead and pull up this file that I already created for the 270. Come on, click on it. Nope. All right. So this is with a 60 grain charge weight, and this is just their numbers. None of this is directly matched to my gun yet. So let's just say if we wanted to run with the 60 grain, which some load data does say that is a max charge, but just for explanation purposes, that's what we'll go with. So you can see down here coming up, it's going to be right around, well, it reads up here, 52,000 psi. That's what that's going to read. Let's just say we use this load, okay? We shoot a 60 grain load. You want to load up minimum 3. I would recommend doing 5. You're going to come up here and you're going to hit this little plus, this little green plus right here, and you're going to add those shots in here. You're going to go charge, okay, and then you're going to put your charge weight in there. We're going to do 60. All right, now we're going to add 5 shots. 2, 3, 4, 5. Okay. We're going to go in here. We're going to edit. These are just theoretical numbers here. We're going to say that this was 3,046. The next shot was 3,033. 3,040 and 3,048. And then we got to go to this last one. We're going to do 3,035. All right. This gives us an SD of 6.6 and extreme sped of 15. Our average velocity is 3,040 feet per second, 0.4. That's the number you want. You want your average velocity, okay? So you're gonna come over here to your results, and what changes that number, your muzzle velocity, is your initial pressure, okay? Your initial pressure is how much force is needed to get that bullet seated into the lands and grooves out of the chamber. That's your initial pressure. Well, you want to get your optimal barrel time and your barrel lead time. And to get that, you have to be, it wants a 10% measurement of what your max is, close to it. And this, you'll understand where I'm going with this here in a second, but right now it shows our muzzle velocity is 2911. We're a 22-inch barrel, we're a 1 in 10 twist. That's, you also got to make sure you got that in there for the gun. Okay, you're going to go to your initial pressure, and we have to start going up with it. Let's just go to 4,500. Let's see where that ends us up at. 4,500 ends us up at 2936. Okay, we need to go more because we need our muzzle velocity over here to match what our average is, which is 3,040.4 feet per second. Let's go 5,000. 2951. We might have to okay, now this is something that's happened on my Wildcats. We keep bringing our initial pressure up to get our velocity match, and we lose our barrel lead time and our optimal barrel time because we're over 10% initial pressure of what the max is. Okay, so we're gonna drop these down. Let's say they weren't that fast. We're gonna say that they were 2968, 2970, 2975, 2960, and 2965. Okay, that gives us an average velocity of 2969, 7 feet per second, standard deviation, extreme spread of 17 feet per second. All right, our average is 2969, so we need to make this match that. So what we're gonna do is we're gonna drop this back down. Let's go to 5,000. Yeah. Okay, not quite there. 5,400. Okay, we're gonna have to drop this down more. This would work a lot easier if I actually had good numbers to go off of. We're just kind of guessing here. Let's do 2950. 2960. 2948. 2955. And 2952. All right. Okay. These numbers should work. So these are our input velocities. This is from our 60 grain charge weight that we shot out of our gun. Okay. Obviously, after we shot all these, we would then take a case. We would measure what our case volume is. Let's just say it's 71.5 grains. Okay. So we got 2953 average velocity. We're gonna come back over here. We're gonna drop this down. Let's see what it said at 5,000. Okay, 2951. Let's take it to 5,200. That's 2956. We went over. We need to be 2953. So we're gonna take our initial pressure. gonna start cutting it in half. We're gonna go 50, 150, 29.55, 50, 100, 29.53.9, and 1.0. Let's take 20 off of that. 50, 80. Getting close. 50, 75. 50, 70. All right, there we go. Our muzzle velocity is now 29.53, which is the same as our average over here from our shot cartridges out of our gun here. All right, so initially what you're doing is you're matching the initial pressure of your firearm to get the mathematical formula of this tool to line up, because you got everything that you're using here. This is your gun that you're inputting in here, and you're getting the tool to line up its formula to your gun, okay, by adjusting the initial pressure. So now, after doing that, it's saying that our load, the max pressures went up to 54,329, which is still good, because the max allowed pressure SAMI spec for this cartridge is 62,366. So then, once you get your muzzle velocity on the tool lined up to your actual average velocity, you're gonna come over here and you're gonna hit the optimal barrel time. Okay, now you want to make sure all these are right. 22-inch barrel. It's going to ask for your barrel, it's just going to tell what your barrel lead time is right now as you got everything input in there, and then it's going to have your average velocity of 29.53. This compensated muzzle velocity comes from the measurements that you input there, your actual shot, your actual muzzle velocities from your gun, from the rounds that you shot. If you don't put those in, you won't get this. You have to put those shots in there. Then you're going to click this. It's going to compute. These are the nodes that the tool has come up with. Now, from their video, one of their videos, it says that 40% of the nodes won't work. Either pressure related or burn rate related, or just that's their error, is 40% of them won't work. So it gives you a couple here to go off of. So I mean, even if you went half, you should be able to hit one, okay, saying that this does work. I have not tested this yet, and that's going to be our next video. So it's saying that node number 5 is 0.02% less than our 60 grain charge weight. So we're going to hit compute node and change adjustment, and it's going to show us where that node is at for what charge weight. It still says 60 grains. So it's saying that where we're at is a node. It's saying that that is a good node, which, given what the SD and the muzzle velocity is, that's pretty fair coming out of just a plain Jane off-the-shelf hunting rifle. Okay, let's say, and it tells you right here, more powder and less powder. So if you're not really happy with the velocity where you're at, let's say you want to go a little bit slower, you want to go a little bit faster, you can look at these other nodes and it tells you. This one says more powder. Let's click on that one. Click it. That's saying 61.69 grains of powder. And your muzzle velocity is going to be at 3,041. but at the same time, you're getting really close to max. So you could risk tearing up brass, you could risk popping primers. So that's what they mean by, 40% of the nodes will work. I mean, it's a computer. It's just gonna spit them out, You yourself have to determine what's safe and what's not. And it gives you a warning down here. If you click the warning, it says, warning, working pressure close to the maximum permissible gas pressure. So let's say we wanted to go less. Let's go down here and we click less. Let's see where that one's at. That one says 58.38. Now, a lot of people don't have a scale that'll read down to 1/100th of a grain. That's no big deal. What I would do is I would just take that to 58.4. You're close enough there. I would say anything over 5, take to 50, take to the next 1/10 of a grain. I just round it up. That'd be your best bet. But what I would do is wherever you want those nodes, I would load up 5 rounds and I would shoot them. See how good they do. This is my best explanation of this tool. I have downloaded it. I've been playing with it for a week, hours on end, trying to get this thing figured out. I think I've figured out the Wildcat section, but I'm not 100%. I'm gonna play with it some more so I can actually verify that what I think is right is gonna work out right. So we're gonna definitely try it some more. I ordered a 6 dasher barrel. When that comes in, we're gonna try that on here, but we're gonna try the 270 first. I figured if this can help some people because we're getting close to deer season, maybe somebody's wanting to work up a load, and with the component shortage, if you can figure out your best load and your most optimal load in 10-15 shots, that'd be awesome. I'm all for saving reloading components to find the sweet spot. That's everybody's goal. Use as least as you can to find how the best your gun can shoot. I mean, you can't ask for much better than that. So we'll just back out of that. But that's the order of everything on here. Cartridge, make sure everything is right over here on this left column. That's all your inputs. You want to make sure that you got the right case length. Maybe your case length's different. Maybe you trim it a little shorter. Make sure that's in there. Your case volume. Not every chamber is the same, so you got to measure your case volume. Cartridge length. Measure your cartridge overall length. That's what it's asking there. Because right here, the cartridge length, overall length, and your projectile length is going to determine your seating depth. Your seating depth is going to determine how much pressure it needs to get the bullet out of the case. So, and another thing that's got to do with that is going to be how much neck tension you got. That's not a measurement on here, but that's where your initial pressure is. Your initial pressure comes from those things, and the formula that they use involves all this stuff. So to get the most accurate number you can for the nodes, they need exactly all of your inputs. Then after you choose your powder down here, you got to make sure you put in the charge weight that you want to shoot. Then you have to be sure to put in your shot data. That's what gives you your corrected muzzle velocity in your OBT tool. Right there. Without your actual shot data, it will not give you this number right here. So you got to put in what you actually shot out of that gun with that charge. So it can correct the tool after you adjust the initial pressure and you get the tool to line up. It's going to correct it then when you run the OBT. And then that's how you get your nodes. So after you get your powder, then you're going to, you've already looked up load data. You're going to go out and you're going to shoot some, okay? okay? It don't have to be at 60 grain, it'd be whatever's safe, you know? Maybe you wanna do a safer load. And so you put some in there, and what you're gonna do is you're gonna go out, shoot them, get some good measurements, and you're gonna put your charge weight in there, then you're gonna put your velocities. And you're come over here to your results, and you're gonna change your initial pressure to get your average muzzle velocity and your muzzle velocity over here lined up. Your initial pressure is what you change to get your two muzzle velocities lined up. Now, another thing that they also say for the OBT is if you're not using a labradar or magneto speed, something that is at the barrel of the gun, there is a corrected yardage or distance away from the gun, so it can tell you that your measured velocity, let's say you're 20 yards from the gun, you're not going to be true muzzle velocity, okay? Because you're gonna drop off some between there and there. So putting that distance in, it'll give you a corrected muzzle velocity. Let's just say we were 10 yards from the gun. Corrected muzzle velocity is 29.74. It's gonna go up. So that's where you would put that in if you're using if you're using like a Caldwell chronograph or anything that you set up out in front of the gun, away from the muzzle. That's what you're going to use a corrected muzzle velocity on. There. Get out of that. So I can't wait to test this and show you guys the results. I think it's going to be great. It's a good tool to use, I think. But it's just I'm being hopeful here. I think if it works, I think it'll be really great. And I just want to kind of put this out there and kind of make other people aware of it. Maybe everybody else can start messing around with it and we can come up with some good stuff for this tool. So, all right guys, I'll catch you in the next video. Thanks.